Section 11.4 is geometry in 3 dimensions. And to talk about this, we're going to start with a vocab, a little bit of vocab. Simple closed curves. Simple closed surface. A simple closed surface has one interior, which is hollow or empty, and one exterior and no holes. So a donut is not an example. There's a hole in the middle, at least. Well, okay, maybe a long john. You can do a long john. Yeah, apple fritters, that would be an example. But a traditional donut, not an example. A solid is a set of all the points on the surface as well as all of the interior points of the object. One such object that fits this criteria is a sphere. A sphere is the set of all points that are a certain distance away from a single point, the center, and the distance from the center to the sphere is called the radius. Sometimes you think of a sphere as a three-dimensional circle, right? It's a ball. A lot of you guys play sports. I know some of you run, so you don't really have, a ball associated with it, but a lot of sports do. Basketball, soccer ball, I know it's not technically a sphere, but it's almost one, all right? Okay, so those are our spheres. Now, a sphere, though, is all the points that are a certain distance away. It doesn't actually include the points on the inside of the object. So in some sense, it's hollow, right? Okay, there is sort of a denseness or a thickness to the actual layer that is the ball or the globe or whatever you're looking at. But that aside, most of them would fit the description of what we're calling a sphere. Hollow on the inside, and then there's points on the surface. All right, another object that's a simple closed surface is a polyhedron. The plural of polyhedron is polyhedra. And you and I are both all going to probably use these interchangeably and not worry too much about them, okay? Doesn't really matter if we're using the word plural or singular, as we know what we're talking about, at least we hope. Simple closed surface with sides, and the sides are shaped like polygons. This actually fits better the description of a soccer ball. So what are the shapes on the sides of does anybody in here play soccer? Okay, Kelsey, is that right? Okay, Kelsey, what are the shapes on the sides of the soccer ball? Do you remember? There's two of them, actually. Hexagon and pentagon. They're both on the outside of the soccer ball, if I'm remembering right, and I might not be, but I believe they're both on the outside. Yeah. So they're both shapes that are polygons. Those are both polygons. Okay. We would call those sides faces of the polyhedron. The vertices, which is plural of the word vertex, of the polygon faces are the vertices of the polyhedron. And the sides of the polygon faces are edges of the polyhedron. So sides are edges, vertices are vertices, and then the object itself are called the faces. And we have a few examples where we're going to decide if in fact these shapes, I think they're on your paper, aren't they?
They are.
Good. Are actually polyhedron. Let's see if they're in the same order. Oh, I think they are. Okay. So just real quick, you're going to write the word yes or no underneath it, hopefully in pencil, or if not, you can mark it out in pen if you happen to get it wrong. So just take your best guess with our definition of polyhedron. Which one are, write down yes, or are not polyhedron, write down no.
Is the one with the cylinder below it a hole?
Yes.
A hole?
Yes.
Okay.
Yes, there is a hole in the middle of that square-ish shape. It's actually called a prism on the, what is it, fifth picture. Okay, just a few more seconds, write down your best guess, and we're going to check them. First shape, what do you think? Polyhedron or not? Yes, because it has a triangle on the bottom and the top, and the sides are all parallelograms, at least maybe rectangles, right? Kind of hard to tell, but one of the two. And those are all polygons. How about the second shape? Yes. Perspective-wise, I would say the bottom is a rectangle or a square, and then the sides are all triangles. Third shape, no. Remember, it has to have those flat surfaces on the side, and a sphere is perfectly round. So this one's not a polyhedron. Fourth shape, no. Got lots of circles going on here as well. Smooth circle-like shapes on the edges. How about what am I on, the fifth one? That one's a no. What's wrong with this one? There's a hole in the middle of it. No holes, right? No donuts, unless they're long johns. And the last one? Yes, no. It's actually no. If it were separated into two pieces, it would be. What's wrong with that? Do you know?
The lines can't cross themselves, right?
Right. If the lines are crossing themselves, which they are, it's not simple. Remember back in, I think it was section 1 or 2 that we defined the word simple? And simple means that they cannot overlap, you know, edges can't cross themselves. And that's what would happen here. Now if these were actually two shapes separately, then we'd be good to go. All right, so we're going to talk about these particular objects one at a time now that we had pictures of. The first one is the one that I used the word for this a minute ago. It's the word prism. So a prism is a polyhedron with two congruent parallel faces called bases. The other faces are called lateral faces, and they're shaped like parallelograms. If they happen to be rectangles, we call it a right prism. If they are not rectangles and they really are parallelograms that slant, if you will, it's called an oblique prism. And prisms are also named by the shape of their bases. So this particular base is of what? The bluish color is a what? It's a triangle. And there's a 90-degree angle. Do you see that 90-degree angle in the back? So that makes that side a rectangle, right? So it's a rectangle, which means we're in this case right here where it's a right prism. And the base is a triangle. So this shape right here, that's not good. I need to use a different color. This shape right here would actually be called a triangular, because the base is a triangle. We need to use the word right. That tells us that the sides are rectangles. And prism. And that is our most specific name that we can go with for this shape.
So if you set it down, would it be a different name?
No.
The rectangle is the base?
No, the bases are always the parallel faces.
Oh,
And since there's only two parallel faces in here, we only have one option for naming it. That's a good question. And with the exception of a rectangular prism, in which case you have rectangles on all the sides anyway, it would only have the two parallel sides like that. Yeah. Okay, so this is a triangular right prism, or you can switch the words right and triangular around. As long as you have all three of those words in there somewhere, we're good to go. Any order you'd like. So we're going to do the following. We're going to label these pictures. Okay, mine are in the same order, so I think yours are occasional. I think I got them all fixed from last semester when some of them were out of order. We're going to label these pictures as best we can visually tell with the language that we used on the last slide. So, what would we call the first one? Looks like a square, right? So I think that that is our intention. It is a square what? Right, because of the rectangles, like you guys said, prism. And I know that the 90 degrees aren't marked, unfortunately. It would be better, again, you guys know I've got issues with finding my images sometimes, but our assumption is that these are marked at 90-degree angles, okay? I'll make sure that I get whatever marked I need to on the test so there's no ambiguity on it. But if those are 90-degree angles, then our description is correct, yeah? Oh, I'd probably need this too. How about that? Will that work? Okay. How about our second picture? It's a pentagon on the top and bottom, so do you know how to take the word? Pentagonal, good job. It's a pentagonal, oblique, because it's clearly slanted, right? Oblique prism. Very nice. Oh my goodness, how many, what do we have on this next one? Octagonal, or octagonal if you want. And then what? It looks like it's a right. Octagonal, right. We'll just put that 90-degree angle in there to be clear. And then we need the word prism. And our last one? Triangular, oblique, prism. Well done. So these are prisms. Everybody good with this one? Okay. The next ones are pyramids. So with the pyramid, or with the prism rather, we have these parallel bases, and with the pyramid there's only one base. And what we have at the top instead is called an apex. So a pyramid is a polyhedron determined by a polygonal base and a point at the top, that apex, that is not in the same plane as the base. The pyramid's shape comes from the triangular faces called lateral faces, determined by the point at the top and the edge of the polygon. The altitude of the pyramid is a perpendicular segment from the apex to the base, and I'll draw that in a minute, and pyramids are named for their bases. So your picture shows a variety of things. One of the things it shows is that these triangles on the sides are the lateral faces. The shape on the bottom, the blue shape, is the base, and the top's called the apex. And then it's kind of hard to draw this one in, but if you drew the line all the way down from the apex to the shape at the bottom, it would be, whoops, at a 90-degree angle. That would be the altitude. Okay? So if you think about a tent is a pretty good picture of this. If you're talking about the height of the tent, you would measure from the top of the tent straight down to the ground. You wouldn't measure along the diagonal side to the ground, right? So that's the altitude, is from the top straight down to the ground. If the base of the regular polygon and the altitude, if the base is a regular polygon, so regular polygon, remember, have congruent sides, congruent angles, and the altitude intersects the base's center, then we have a right regular pyramid. So the word regular has to do with the fact that the base is regular. If the altitude does not intersect the base's center, it's oblique. And again, visually it has to do with whether we imagine it standing straight up and down or if it's leaning. Is it at a slant? Okay, slanted means oblique, and it's straight up and down, perpendicular. We have a right angle hitting the bottom.
Why did you say we put the regular in there? What's it like referring to?
Regular is referring to the bottom of the shape, these sides being all equal, and the angles being all equal. So it's a regular polygon at the bottom.
So if it was like a, oh, okay, so it's just regular, it doesn't have to be like
Yeah,
square,
like
it
we
doesn't
could
have
call it,
to
like on the last one, well, let me just say, if it's oblique, it's not possible. Is that not true? That's not true. If it's oblique, we can still have an oblique regular pyramid. We don't see those very often, but if we had a square on the bottom, we could still have our tent slanted, if you will,
Yeah.
and that would be okay. So you could have an oblique regular pyramid. But the more common one to see is a right regular pyramid, or an oblique pyramid where that's not the case.
Is it kind of like when we defined regular on one of the questions on our homework where it was asking, like, is it regular if all the angles are congruent? Well,
Right.
not necessarily, but we don't know if the sides are.
Right.
Like that.
Exactly. So in order for it to actually be regular, the shape at the bottom needs to be regular, which means it has congruent sides and congruent angles.
It doesn't need to have like right angles with the rest of the shape. It's just the
No,
base
the
itself.
right angle that it's hitting is actually right here. So when it used the word right in this location, this word right is referring to this angle right here, being a right angle.
So is the one at the bottom not doing that?
It isn't marked. It might be. It's sort of drawn in such a way that I'm led to believe that it's a parallelogram maybe at the bottom and not necessarily a square.
Okay.
But if it were a square, it'd be okay. Okay, I'm going to talk a little bit about how we draw in 3D. Drawing the base is One of the big things, you got to draw the base accurately. And then parallel vertical segments of equal length connecting endpoints of the segments. Or if they aren't parallel vertical segments, they might be, like if you're drawing a pyramid, they actually might slant. So if you think about drawing, I'm just going to show you what I mean by some of this description. So if we were drawing a, let's go with a square on the bottom. You can't draw a square like this and then turn it into three-dimensional. I'm not an artist, but I know perspective doesn't work like that, right? You have to draw it at an angle to start with. So somehow you're going to draw, I'll draw this piece, these pieces to look like they're the same length, but they're 90-degree angles because you're getting the perspective in there. So these are all 90-degree angles. If you want a parallel, if you want a prism, you're going to draw the same image straight above it, but the easiest way, and the way that it's describing this to do this, is to take straight vertical segments and draw them up the same length. So notice from where I am, I've gone straight up, in my picture, 3 units, a little bit over 3. So I would have to do that from every single object. So I'd be going up, you know, the same length or the same distance up from where I was before. And my picture's not going to be perfect, neither is yours, but we're going to try and make them as convincing as we can. And then we connect those corners after that. So it's not perfect, but it's not too bad. Hi guys, just watch the rest of the video on your own, okay? So that's not too bad, right? Sorry, they're headed on a field trip to Will Rogers. So we only have 5 minutes left. You guys are going to survive just fine. If you were doing a pyramid, let me just show you real quick how to think about that. So we're going to draw our base of our pyramid. We'll still draw a square. And we draw our apex. So if we want it to be right here, say, we will connect that point to each one of our vertices to get our three-dimensional shape. And I do realize that my technology lends itself well to straight line segments, whereas maybe your pencils don't. But you're welcome to get out, you know, something with a straight edge. ID cards are fantastic for giving you a straight edge that's very firm, and you always have it with you. So driver's license or something like that with you. So this would be a pyramid, and if you were drawing it so that you were clarifying for sure that it is, say, for instance, a square down here at the bottom, you can mark your sides and you can mark your angles and so forth to indicate that it is a square on bottom as opposed to something else.
Do we have to measure, like, what, how many right angles do we have to mark? Like, is 2 okay then?
1 would actually be enough in the bottom as long as you marked the congruent sides as well. Yeah, all 4 congruent sides. Now you're not going to be judged too strictly on your drawing, but they need to look a little convincing, okay? Yes, Asia.
Can you repeat how you did the second one? I was still doing
The pyramid, you mean? Yeah, I drew the square on bottom just like we did in the first one, and then I put an apex, a point up in midair, and I connected that point back down to each one of the square's vertices. Okay, this is an identification one, example 3. We're going to identify which of the following are convex polyhedron. So we need to know what a convex polyhedron is. It's a polyhedron where any segment connecting any 2 points is in the interior of the polygon, I can't read even. When we did convex before, it meant you can't go outside the shape to connect points, correct? The same thing's true for a convex polyhedron. If I take 2 points in the shape and I connect them with a line segment, the line segment needs to be inside the shape. Otherwise, it's not convex, or we could say it's concave. So the first picture, is this convex or not convex? This one is not convex.
Is it called concave or is it just not?
Our book doesn't use the word concave for this. I don't think there's anything incorrect about saying that, but they don't use it for this particular one. So if I were to connect, and I'll just use a point on the edge so I draw out easier, these 2 points, I'm actually outside of the shape automatically, and any of the points on those 2 faces would do that. How about the second one, convex or not convex? This one is convex. And your third one? Convex. All convex shapes. All right, we will do one more slide and pause for today. 3D vocabulary, regular polyhedron. A convex polyhedron whose faces are all congruent and all regular polygons. So we can't do a combination of, what did I say, hexagons and pentagons like a soccer ball? We can't do that and have this shape. This shape has all the same shapes on every face. So each vertex of a regular polygon has the same number of edges. There are only 5 shapes that do this, only 5 regular polyhedron. And these 5 polyhedron are called Platonic solids. There's only 5 of them. And you've got wonderful pictures here, and I promise I won't make you draw these pictures for them. You're welcome. And we will pick up next time with the names of these 5 interesting shapes and finish up section 11.4.